is all about laws of exponents in equations, I thought it's a good idea to revise the laws of exponents. So let's see if we remember all the laws of exponents before we use them or apply them today. Okay, so law number 1, right? For all of those who remember, law 1 says if you are multiplying two powers that have the same base. So if you look here, our base is x, right? And we are multiplying. If that is the case, then we are going to add the exponents. So we took whatever exponent was there, plus whichever exponent was there. If there is no exponent, for instance, if I just tried x, then what is my exponent? I know you guys know this. If I do not have an exponent, thank you, Iminati. If there's nothing, then my exponent is 1. Okay, it is not 0. All right. Law number 2 is probably, I would say, the opposite of law 1. Because this time we are saying we are dividing the two powers. So in law number 1, we multiply. Law 2, we divide. Once again, same base. And if that is the case, we are going to subtract the exponents. Okay, so multiplication is add, division is subtract. So these two are very similar to one another, I would say. All right, let's move on to law 3, which is power to a power. So what this means is you already have a power. Now, if we revise and think about what a power is a number with its exponent. So if I say 2 to the power of 4, this whole thing, this whole expression here is a power. Okay, so if you have a power and you are raising it to another exponent, so this time we have 2 exponents. In that case, you multiply those 2 exponents that are at the top. Okay, like these two. So here we have an A and a B, so we multiply them. And then we have the last law before my definitions. The last law is the distributive law. So if you look here, this law says if you have 2 bases, so in this case, I have an X and I have a Y, right? Or 2 powers rather, because X is to the power of A and Y is to the power of B. If this is the case, and all of this is raised to another exponent, then you distribute it. So then you multiply the exponent of X with your power outside and the exponent of Y with the exponent outside. Okay, this is an extension of law 3. Law 3, the only difference is that in law 3, there's 1 base, but in law number 4, there's an X and a Y, which means there are 2 bases. Now, I need to remind you guys, okay? In this case, we have 2 bases that are multiplied, but if you have 2 bases that are divided, for instance, let's say I have x squared here divided by y to the power of 3, and I'm raising all of this to the power of 7. This is also the distributive law. What that means is that you will take your power of 7 and distribute it to the x and to the y, which will give you the x squared to the power of 7 over my y cubed to the power of 7. All right, and then you apply law 3, which says you multiply these. So it's x to the power of 14 over y to the power of 21. All right. And then we have definitions. So those are our 4 laws that we discuss and go over and talk about. Then this time we have definitions. So we mustn't confuse laws for definitions. Okay. So definition 1 is anything to the power of 0. We all know this one. What is anything to the power of 0? What will my answer be? It's 1. Don't get confused. It's not multiplication by 0. It is power of 0. Okay. So anything times 0 will be 0. But in this case, we are putting 0 as an exponent. Anything to the power of 0 is 1. And the definition number 2 is the negative exponents. So if you want to change the sign of your exponent, okay? A lot of the times when you are doing anything to do with exponents, your instruction will say, leave your answer as a positive exponent. If that is the case, then you're going to use this definition. Okay, so to change the sign, then you find the reciprocal. What does reciprocal mean, guys? In simple and plain English, can someone tell me what reciprocal refers to? If I say to you, find the reciprocal of something. That is an example, but what does it mean? If I have 3/4, what's the reciprocal of 3/4? Let's hear. The reciprocal of 3/4, it means you are swapping the numerator and the denominator, right? So then the reciprocal of 3/4 would be 4/3. Do you guys see? So in order to change the sign of an exponent, then you look for the reciprocal. Okay. Obviously, there are other times when we use reciprocals, such as when we times fractions and we want to do the keep, change, flip. That's another example, but in this case, it's to change the sign. What we mean is, if I have 2 to the power of -2, this is automatically over 1. Do you guys know that? This is over 1. So in order to change this exponent to a positive, I have to move it down. So it'll be 1/2 squared. But it works the other way around, okay? So if I have 1/2 to the power of, let's say, 4, and I want this to be in my numerator, then I can do that. I can move this up, but then my exponent will change to a negative. Okay, hopefully I have reminded us of the laws of exponents enough for us to apply them in the lesson. Let me zoom out in case someone wants to take a screenshot. Okay, some more. There we go. All right. If there is any law that doesn't make sense, then you raise your hand and you ask so that I clarify for you before we continue with the lesson. Okay, guys. Right, let's get going. So I'm going to zoom right back in and get going. Okay, now we have equations, right? Algebraic equations. We know they're equations because we discussed there is an expression, an equal sign, and an expression. Now, these equations have many of the same rules. In other words, I want all of my variables to be on one side and all of my constants on one side. In this case, they've already done that for us. Not all of them, actually. I just looked properly, but we'll see what I mean just now. Now, let's look at the first one. Y squared is equal to 36. Let's think of our inverse operations that we learned last week. How would we solve for y in this case? We would have to use the inverse operation of a square. And what is inverse of square? What is my inverse operation for square? It's not division. Thank you, Seth. Seth is the only one who's trying, guys. Where's everybody else? Let's hear. It's not divide, guys. What is the opposite of squaring? Division is the opposite of multiplication. And addition is the opposite of subtraction. So what is the opposite of squaring? Nice, Seth. Nice. It is square rooting. Okay, so it is square rooting. So if I want to get y on its own here, then I will have to square root this y because these two will cancel each other out. Do you guys see that? But if I'm going to square root the left-hand side, then I have to square root the right-hand side. But what is the problem with square rooting the right-hand side? Before I can do that, what do I need to add? Why can't I just square root the right-hand side? Does anybody remember? Okay, let me remind us, okay? Let's first find the solution for this. So then this will give me just a y because these two cancel each other out, okay? Y is equal to, what is the square root of 36? It is 6. So we all agree it is 6, right? But is that the only square root of 36? Is that the only square root of 36? What do we think? What is the other one, Seth? -6. Thank you. So remember I said, if you introduce a square root, right? In my original question here, did we have a square root? Look at the question as it stands in the beginning. Y squared equals 36. There was no square root, so we introduced it, right? If you do that, then you have to add the plus minus. What does this plus minus mean? Let's unpack all of this. What does this plus minus mean? Does anyone know? It means that y is the positive square root of 36, but it is also the negative square root of 36. So then my final solution is y equals to 6 or y is equal to -6. Do you guys understand that? That's because if you say -6 all inside a bracket squared, what is my answer going to be? This gives me -6 times -6. And what is a negative times a negative? It is a positive 36. So do we see that in order to find 36, you can either square root a positive 6 or you can square root a -6 and you can still get 36. There are always two solutions to a square root. If the question was given to us like this, where they said y is just the square root of 25, then that's fine. It's just 5, right? Because there is no plus minus there. But our original question did not have a square root. We are the ones that put a square root there, which means we must say that there are two possible solutions here. It could either be the positive square root or the negative square root. Do we understand that? Can I have a thumbs up, thumbs down on that concept? As anytime you introduce a square root, you say it is either positive or negative square root. All right. Wonderful, guys. I like those. I only have 2 or 3 thumbs up, but I'm hoping everybody else understands still. There we go. Nice, guys. Thank you. That's better. Okay. Now let's get going. I'm going to leave this on the screen in case you go back and you want to look. Now let's move on to B, which is an exponential equation. Do we remember how to do exponential equations? Let me check here. Let me first write it. We are saying 3 to the power of x plus 1 is equal to 1. What are my rules when we are doing exponential equations? So the difference between A and B, right? In A, our variable was the base. Can you see that y is the base, which is my variable? But in B, my variable is in the exponent. So that is what distinguishes these. You cannot divide or times or do anything with this because my variable is in the exponent. It's a problem for us. So how do you think we would solve this one, guys? How do you think we would solve this? Is there anyone who's familiar with algebraic equations? Let me start there. Nice, Butlale, we want our bases to be the same. Now we have a problem here, right? On my left-hand side, I have a base of 3, but on my right-hand side, I have a base of 1. Is there a possible way to make 1 the base of 3? I can't change the one on the left because there's a variable, right? I cannot change that. But is there any way I can make 1 something with a base of 3? What do you think? Seth says yes. How can we do that, Seth? Let's think of our laws and definitions of exponents that we just went through now. Look through those laws quickly. Where does 1 come in with those laws? Nice, guys. 3 to the power of 0. Do you remember my definition 1, the power of 0 says anything to the power of 0 is 1. Therefore, I can then say, if I have a 1, that this can be rewritten as 3 to the power of 0. Beautiful, Butlale and Seth. You guys are doing wonderful teamwork in the chat there. Okay, now we have the same bases. Butlale, any idea where we go from here? Any idea where we go from here? I like it, Seth. You guys must keep it up. Once the bases are the same, then... Okay, they are the same. So what can we do? Just remember what an equation means, guys. Nice, Seth, that's true. We bring the exponents down, but we need to understand why, right? My equation, this equation says the left-hand side is equal to the right-hand side. Do you guys agree? So this equation is saying 3 to the power of something that we don't know is equal to 3 to the power of 0, right? That means that this something has to be 0. So they are equal. Do we understand that, guys? It's very important that you understand how equations work. They are telling you that the exponents are equal. If I say 3 to the power of a mysterious number that I don't know is the same as 3 to the power of 2, then what is that mysterious number that I don't know? What do you think? It has to be a 2, Butlale, right? Purely because of the equal sign, telling us that the left-hand side is equal to the right-hand side. Nice, guys. So let's get going. Now that we understand that concept, do we understand why we can now say that means that x plus 1 has to equal 0? Are you with me, guys? Hopefully this makes sense why we do this. Okay, now we have normal equation now. X plus 1 is equal to 0. How am I going to solve for my x? How am I going to solve for x? Transpose. Okay, 1 has to go away. What happens when 1 goes to my right-hand side? It is currently a positive 1. There we go. That means we'll be left with 0 minus 1. Therefore, x is equal to -1. Beautiful, guys. That was lovely teamwork over there. Okay, maybe I should organize my screen a little bit more. I'm writing as if I'm making study notes for myself here. Everything is everywhere. There we go. Okay, I'm going to write C on the side here. Okay. C. 2 to the power of x times 2 to the power of 3 is equal to 2 to the power of 7. Okay, this one, they were very kind to us by making the bases the same. Do we see that? I have a common base of 2 everywhere. So I don't have to change my bases to be the same. All right. The only problem now is that I have more than one base on the left-hand side, but we can solve that problem using laws of exponents. How can we solve that problem using laws of exponents? What do you guys think? How can we solve this problem using the laws of exponents? We have two bases and we are multiplying. What do I do according to laws of exponents if I have two bases? Nice, Botlhale. Beautiful. We add the exponents. So then on my left-hand side, I will have 2 to the power of what plus what? If I'm adding the exponents. X plus 3, because those are my exponents on the left-hand side. So 2 to the power of x plus 3 is equal to 2 to the power of 7. Once again, we are in that position where we say 2 to the power of something. In this case, that something is x plus 3 is equal to 2 to the power of 7. That means my something has to equal what, guys? My something has to equal 7. Beautiful, Seth. You guys are lovely. So then x plus 3 has to equal 7. Once again, we get rid of the 3 by taking it over to the other side, which changes its sign. So then x will be equal to 7 minus 3. It was a plus, went over the equal sign. It is now a minus. Okay? Therefore, my final answer will be x is equal to 4. Nice, guys. All right. Feels like we're doing well here. And I like this division thing I'm doing because it's organizing my thoughts as well. Let me do it again. Okay, let's move on to D. Let's move on to D. This time we have a division, which we haven't had so far, right? We've had a lot of multiplications, so let's see what happens with divisions. Look at our laws of exponents. Tell me which of the laws makes you think of this. Which of my laws and definitions reminds you of what I am looking at right now? I have a x over 2, excuse me, all to the power of 2 equals 16. Beautiful. Botlhale, that would be the law of distribution. Is there any other way we can solve this though? I'm going to go ahead and go with Botlhale's idea of distribution, right? We have two bases, an x and a 2. In brackets and an exponent outside both of them. So we distribute. That means this 2 will be distributed to the x and to the 2 in the denominator. All right. Now, currently x and 2 do not have exponents. So we said if there is no exponent, what will the exponent be? If there is no exponent, then the exponent is 1, right? So if I distribute here, it's going to be x to the power of 1 all to the power of 2 over 2 to the power of 1 all to the power of 2 equals 16. What happens with these two exponents here? Now we have changed to the law of power to a power. What happens with those two exponents? We multiply. Lovely, Seth. So then we have x to the power of 1 times 2, which is just x squared, over 2 to the power of 1 times 2, which is 2 squared. All right. And this is equal to 16. Now, does this not look like an ordinary sum of solve for x? Because in my numerator, I have x squared. And in my denominator, I have 2 squared. But we can simplify 2 squared to what? What can we simplify it to? Over 4 equals 16. And the point of this whole sum is we want x squared to be on its own. So how am I going to get rid of the 4 in my denominator? We did this in the previous lesson. How do I get 4 away from my denominator? Inverse operation 4? No, that would not be getting rid of it, right? That would not be getting rid of it, guys. That suggestion that Buhlali and Seth are making is a good suggestion, but that is great if we have a variable in my denominator. Do we see that we have an actual number in the denominator? So we can find a solution. But what is the inverse operation for division, guys? Remember, we are getting rid of it. So we times both sides by 4. And why do I want to do that? What are these two 4s going to do on the left-hand side? What's going to happen with my 4s on the... Thank you. They're going to cancel out because one is in the numerator and one is in the denominator. And I've successfully gotten rid of it. So then I'm going to continue on the side here, okay? So then I'll be left with x squared on my left-hand side. And on my right, I have equals. What is 16 times 4? 64. Nice, Buhlali. We're almost done. We're almost there. Okay. Now let's see. How are we going to work with this one? I want x and I currently have an x squared. How did we say we're going to find x when we have an x squared? We did it in the very first sum today. We rooted. But what do I remember when I root both sides again? Something about introducing a square root. Because there was no square root, we have just now introduced the square root. Nice, Seth. It is positive or negative. Then that means my two solutions for x is equal to, my two solutions, it will be x is equal to, what's the first one? What's the square root of 64, guys? Nice, 8, or x is equal to negative 8. You guys are getting this. Okay. And then I have E, which is slightly a bit more challenging, but not too much. Okay, I'm going to show you just now why it's not that bad. Now, E is a bit different. What's different about E, guys? You need to learn to spend time with your question in an exam, okay? You can't just look at it and know what it is. Just give me your ideas. Okay, Buhlali says base. Which base are we referring to here, Buhlali? And what about it? Okay, the base is on the left. What's happening with the bases on the left? Is it one base? Or are there two bases? Let's start there. Is it one base or two bases? On my left. It is two bases. Thank you, Iminati. So this is a common, I don't know, misconception or confusion that happens with us as well at work. Well, where I teach, okay? Let's clarify this comma situation, this dot and comma situation, okay? We have a 3 and a dot and a 2 to the power of x. This is not 3, 2, okay? So I know that we use a lot of resources from other countries and whatever, but in South Africa, when you have a decimal, we use a comma. Okay, so we're never going to say 1 like that and say that's 1.5. In South Africa, that is 1 times 5 because that is a dot. If I want to say 1,5, then I use a comma. All right, guys. That is something very valuable that has just been brought up now. So do not forget that we do not use dots as a comma. So this number that we have here, I know it is easy for us to confuse it for 3, 2x. It is not 3, 2x. It is 3 times 2 to the power of x. Okay. Now, here's my question. Are we allowed to first times these two? Can I say then it's 3 times 2, then say 6 to the power of x? Am I allowed to do that? Let's hear what we think. Okay, we have different opinions here. Seth says yes, but Sponginkosi says no. What does everyone else think, guys? You shouldn't have to be so quiet. What do you think? Are we allowed to multiply these bases together and say that means it's 6 to the power of x? What do we think? Okay. I have another no. Okay, let me clarify first. We cannot do that for a very simple reason of a bit mess. Okay, look at this expression 3, a multiplication and a exponent. Between multiplication and exponent, which one comes first? Between multiplication and exponent in BEDMAS, which one do we do first? Look carefully. Exponents, it's the second one. There it is over there. And multiplication is all the way there. Can we simplify this exponential expression? It says 2 to the power of x. Is there anything that we can do about that? 2 to the power of x. No, there isn't. Okay, because we don't know what x is. If it was 2 to the power of 2, then we would have simplified it to 4. Do you see? So in this case, we actually cannot do anything about this expression on the left. You cannot multiply it and you cannot expand the exponents. What you can do is get rid of all the numbers surrounding x. Okay, this is what I mean. So I have a 2 to the power of x times 3. That times 3 is a problem. Can I get rid of times 3? Can I get rid of times 3? Yes, Seth. How do I get rid of times 3? I carry it over and it becomes, what's my inverse operation for times? My inverse operation for times is division. So I can divide my left-hand side by 3, but whatever I do on the left, I have to go do on the right. And look what that's going to do. What are these 3's going to do? 3 divided by 3. What happens there? I'm going to end up with a 3 divided by 3, which causes them to cancel out. Beautiful. So then I am left with 2 to the power of x is equal to, what is 24 divided by 3? 24 divided by 3 is 8. Beautiful. Okay. So if all else fails, get rid of everything around that x or the term with the x. Okay, now let's look. Okay, I have 2 to the power of x is equal to 8. We go back to Bohlale, I think, suggestion that my bases has to be the same. In this case, I have a 2 and an 8, which is a problem. Is it possible to change 8 to something with a power of 2? Which is what, Bohlale? 2 to the power of x is equal to... Oh, check again. It's not 2 to the power of 4, nice or funny. It's 2 to the power of 3. Do we know how to change our numbers to prime factors? These are prime factors. Do you guys know how to do that? Or do you remember rather? Let me say, do you remember? Let me not say, do you know? Do we remember how we change our numbers to prime factors? It's fine. I'm going to find out just now, okay? Now my bases are the same. So what do we do? My bases are the same. Then I can make my equations, my exponents, my exponents equal. So therefore, x equals what? Therefore, x is equal to 3. Nice, guys. Wonderful. That was a nice long warm-up for us today. Can I ask that you guys go 2 reactions and you press a thumbs up if you understand, and a thumbs down for any of the 5 that we just know. How did I get 3? Remember, wait, if the bases are the same, 2 and 2, then my exponents are equal. Okay, because what this says is 2 to the power of something is the same as 2 to the power of 3. So what does that something have to be? What does that something have to be? It has to be a 3. Does that make sense? Hopefully it makes sense. You're welcome. Oh, there we go. I'm getting my nice reactions today. I see Alien and Angel. Wonderful, guys. I did not zoom out for people who wanted to screenshot. There we go. Okay. Now, view, zoom back in. Okay, now I have another set that we can do over here that's going to challenge us a little bit more. Okay, are we ready to tackle these? Just follow the rules that we learned and we will be able to do these. But these are a little bit more spicy, if I can say. Okay, a little bit more spicy. So let's get going, okay? Remember, guys, anything you see in a maths paper is stuff you have done before. So there is no reason to freak out. You just remember your rules. So let's look at the first one, right? Let's look at the first one. A says a 2x to the power of 3 is equal to, nope, the 3 is outside. The 3 is outside, sorry. Is equal to 1,000. Great. What laws of exponents do we know that can help us solve this? Let's hear. Look at your laws of exponents. Nice. Nice, nice. You guys see? See, it's stuff you know. Distribution. So we're going to take this 3 or power of 3 and distribute it because we have 2 bases inside. So then I'm going to end up with 2 to the power of 3 times x to the power of 3 is equal to 1,000. What is 2 to the power of 3? Let's simplify that. 2 to the power of 3 is 8. X cubed is equal to 1,000. Can you see it doesn't look as bad? I said if all else fails, you try and get x on its own. So this case, we want x on its own, so 8 is a problem because 8 is next to x. How do we get rid of that 8? How are we going to get rid of that 8? Nice, Iminati. We're going to divide by 8. But what I do on the left, I have to go do on the right. So I'm going to divide by 8 here and divide by 8 on that side. What are these two 8s going to do? 8 divided by 8. What is that going to give us? They cancel out. So I'm left with x cubed on my left-hand side equals 1,000 divided by 8. And what is that? Thank you, guys. It is 125. Oh, now we have a new inverse operation that so far we have not dealt with, okay? Remember we said the inverse operation for squaring is square rooting. So what is the inverse operation for cubing? My inverse operation, nice. Oh, fabulous, guys. You guys are so amazing. It is a cube root. That means I shouldn't have written this so close. To make space for my cube root. That means I'm going to cube root this side and this side. Do I need the plus minus in this case? No, we don't. There's only one solution for this one. So then we cube root both sides. That means I'm going to be left with therefore x is equal to, what is the cube root of 125. That would give us 5. And we are done. Okay, A wasn't that bad, was it? See, I'm not out to kill you guys. Just to make life a little bit interesting. All right. Let's see if we can tackle B. I know some of you are staring at C and thinking, what on earth? Don't worry, we're going to get there. Okay. B. 7, 5 to the power of x minus 9 is equal to 166. Wonderful. Okay. So I just said if all else fails, what do we do? What do we do if all else fails? You have no idea what to do. I said something. I said if all else fails, you get rid of everyone around x. Nice, Imi. You get x on its own. You can't give up, Seth, because this could easily be worth 6 or 5 marks. So if you give up, you lose all of those marks. Are you guys willing to lose those marks? I don't think so. So let's get going. Okay. So I want x to be on its own. There's x over there. Let's identify it. There. Okay, what is the first thing we can get rid of around the x? As in, what is the first thing on the left-hand side that I can get rid of? Okay, I see you guys say 7, but there's something else we can get rid of on the left-hand side. Nice, guys. It's easier to get rid of this 9. Not the 7. If I divide by 7 here, I have to divide by 7 here and there. And now you're working with a fraction. Is that smart? That is going to take forever. So first do the subtraction and addition. Then you do multiply. Remember, I said reverse BODMAS. Okay. Now, let's get rid of this negative 9. How do we get rid of it? It is currently on my left-hand side. I want it to go to the right-hand side. So what's going to happen with it? Nice. It's going to be a positive 9. So I have 7.5 to the power of x is equal to 166 plus 9. What is 166 plus 9? 166 plus 9. Thank you, Seth and Buhlali and Iminati. That is 175. Great. We've gotten rid of the 9. Now, once again, what does this dot mean? Is it a comma? What does that dot mean? It's multiplied. Thank you, Seth. So then, how do I get rid of my 7? Now that we know it is a multiply. How will I get rid of the 7? We will divide by 7. Nice, Buhlali. But what you do on the left, you go and do on the right. All right. Now these 7s will cancel out, which means I will be left with my 5 to the power of x on this side is equal to 175 divided by 7. What is that going to give us? 25. Nice, Buhlali. Enofani. Okay, we are down to, we've gotten rid of everyone around x. So what do we do now? What do we do now? I have one term on each side. But the problem with those terms is what? Nice, the bases are not the same. We do not divide, guys. Division is an inverse operation for what? Let's discuss this. Division is the inverse operation for what? Multiplication. The only time you are allowed to divide is if the 5 is next to my x. But do you see that the x is in the exponent? So if you divide by 5, is that going to solve anything? No, it's not going to solve anything because the 5 is not next to the x. It is the base. All right. Do we see that? We have to see that. Guys, be careful. Be careful. Now, let's make our base the same. We don't square root either, Seth. We make our bases the same. How do I rewrite 25 as something with a base of 5? Nice. So then I have 5 to the power of x is equal to 5 to the power of 2. Now my bases are the same. What do we do? What happens after the bases are the same? If 5 to the power of x is equal to 5 to the power of 2, then what does x have to be? X has to be 2. Nice. Are we ready to tackle C before we go and do our quiz? C is the last one for the day, which I think is very fitting. If you look at it, I'll do it just below this. Wade is like, no, give me a 0. I don't want to do C. Let's do it. I know you guys can do it. Just think of all the rules you know, okay? It's going to be so much easier than you think, Wade. I promise. Okay. 2. I said I'm going to put a division here so that these numbers don't overlap and look like one question. There we go. So I have a 2 cubed times 2 to the power of x over 32 is equal to 2 to the power of x to the power of 3. Now, what is your big clue here? I have a bunch of 2's here. So what do you think must happen? I have a 2, another 2, another 2. So what do you think we can do with my 32 at the bottom? Can I rewrite 32 as something to the base of 2, excuse me? Is it possible to do that? Let's hear. Guys, if you don't remember on your calculator, remember you press 32, the number, then you press the equal sign, it's going to write 32. Then you press the shift button, which is top left, and then you press the factors button or factorize button. This is the comma one. The comma and the dots and the whatevers. Yes, so 32 is the same as 2 to the power of 5. Okay. So, now that everything is to the base of 2, do you guys see this is not that bad? Right? This is not that bad. Let's take one side at a time. I'm going to take the left-hand side. How many laws of exponents do you see here that we can apply? I have a multiplication, I have a division, but everything is to the base of 2. What do you think, guys? Let's start with multiplication. When we are multiplying and they have the same base, what do we do with the exponents? We add them. So then in my numerator, I can have 2 to the power of what plus what? Nice. 3 plus x. And this is all over 2 to the power of 5. Okay. Now let's go to the right-hand side. Power to a power. What am I going to do with these exponents? This time I have exponents to another exponent. So how do I simplify that? We multiply. So then this is x times 3 or 3x. Does it already not look better, guys? It already looks much better. Now, on my left-hand side, I still have a division symbol. And laws of exponents say what happens when you have division and the same base? Division and the same base, you subtract your exponents. So then on the left-hand side, I'll have 2 to the power of 3 plus x minus 5, because the 5 was the one at the bottom, is equal to 2 to the power of 3x. Ha! Would you look at that, guys? We have the same base, 2, 2. Same base means exponents are equal. Okay. I'm going to write it here. Same base, exponents equal. So that means 3 plus x minus 5 is equal to 3x. Okay, now let's solve this. This is a mess. X's are on everywhere and numbers are on the other side. I want x's to be on one side and numbers to be on the other side. So what are we going to move here? Nice, we can move my x. So this x can go over, and when it goes over, it becomes a 3 minus 5 is equal to 3x minus x. Okay, on this side, I have a 3 minus 5. What's 3 minus 5? Negative 2 is equal to 3 minus x, which is 2x. I still have a 2 in front of my x. How am I going to get rid of that? Divide. Nice, guys. Divide. These will cancel out. 2 divided by 2 is gone. Therefore, x is equal to, now I have a positive and a negative here. So my answer is going to be what? Nice, so funny, -1. Beautiful, guys. Can you see that wasn't that bad? Okay, let's have a final thumbs up, thumbs down